Alright, this is the midterm exam for Physics 204. That's 1R, spring 2011. It says to draw 6 electric field and equal potential lines for this configuration. And for each, let the field and potential lines span the entire region within the rectangle. And then for the second configuration, to show how the charges are distributed. So here our electric field lines run from positive to negative. They're going to look like this. It's just like we did in lab. Here it runs straight across. Let's see, I need 6 lines. Throw in another one there. And then my equal potential lines are perpendicular. So they look like this. And at each point, they're perpendicular to the field lines. They begin to flatten out as we get over here. So that should be a straight line. Look just like that. Now on this one, that's what I was looking for. Your field lines. Let's see. This one is supposed to be positive, and it was on your exam. The field lines on the outer regions just run straight across, and they're unaffected by the charge in the middle. You get an induced charge here that is negative and positive on that side, and your field lines in the center are going to curve around, go into that, and then come out of it like that. And then you also get some that sort of just curve in like that. And then likewise over here. And then your equal potential lines over here are just going to be straight across, and they will begin to curve around the sphere in the middle. Some of you thought that you were just supposed to draw the charges in the middle, and I understand that the question was sort of poorly worded, and so I didn't count off for that. Alright, so that's how it should look. So that's what I intended. Alright, given this data for a particular circuit consisting of a resistor in series with a power supply, determine graphically the voltage provided by the power supply. So this is the graph that you were supposed to create. Current on the y-axis and 1 over resistance on the x-axis, and then you find the slope of that line, and the slope is 4 volts. Alright, some of you got a slope that is a little different, but the slope of this line really is 4 volts if I do a least squares fit to it. But I accepted anywhere from say 3.7 to 4.3 or whatever. Alright, this graph shows voltage versus length for a slide wire like used in the lab. The current was kept constant at 2 amps. Collect this data to determine the resistivity of the data. Well, first you have to find the slope of this line. Draw a best fit line, find the slope, and you find that the slope is around 18. I found the slope to be 18.2. Right. Again, I accepted slopes within a reasonable range of that 15 to 25. Now, I want to, I know that V is equal to V. My pen is not working today. That V is equal to I. V is equal to IR, and R is equal to rho L over A. Right, I want to put an expression that has V on the left side by itself and L on the right side. So I'm going to say I'm going to replace R here in this equation with V over I, and V over I is equal to rho L over A. Rearrange this equation, and I have V is equal to rho I over A rho I over A times L. And now this then is my slope. So I set my slope, which is 18.2, equal to rho times I, which is 2 amps, over A, which is 2 times 10 to the minus 6. And if I solve that for rho, my rho is equal to 1.8 times 10 to the minus 5. That's in ohm meters. That's the answer. Alright, consider the following circuit. What is the equivalent resistance, the potential across each resistor, and the current in each resistor? Alright, well first we have to find the equivalent resistance. The resistance of this is 1 over 1 over 6 plus 1 over 3, which of course is equal to 2 ohms. And that gives me an equivalent resistance. I have a circuit here with a 4 ohm and a 2 ohm. So that gives me an equivalent resistance of 6 ohms. And then I want to know what is the potential across each of these. When I have 10 volts here, that produces a current, I'll call it the equivalent current, equal to V over R, which is 10 volts, over my equivalent resistance, which is 6 ohms. So that is 5/3 of an amp. Alright, so that, by the way, also is I1. 5/3 of an amp is the current through this 4 ohm resistor, which is right here. Now, I can also find my potential across that 4 ohm resistor. V1 is equal to I1 R1. So that's equal to 5/3 times 4, which is equal to 20/3 volts. So for V1, I have 20/3 volts. 20/3 is equal to 6.7 volts. And then V2 and V3 are going to have the same voltage, and that voltage across this resistor is equal to 10 minus 20/3, or 10 minus 6.7, which is 3.3 volts. So V2 and V3 are both 3.3 volts. Alright, and then I want to find I2 and I3. I just say I2 is V2 over R2. V2 is 3.3, R2 is 6. That gives me 0.55 amps. And then I can say I3 is V3 over R3, and that's equal to 1.1 amp. Alright, I can either do that, or I can say that I3 is equal to I1 minus I2. That's from the junction rule, and that's also equal to 1.1 amp. This, by the way, is equal to 1.7 amps. I gave a variety of partial credits for this. Like, for example, if you got these two numbers to be the same, but they were the wrong numbers, then I gave you credit for one of them, but not for the other. And also, if you got the potentials wrong, but then you used them correctly to find the currents, then I gave you credit for the currents, but not the potentials. Right? So I gave a variety of partial credits for this problem. Describe how a voltmeter is constructed. A voltmeter consists of a galvanometer with a large resistor in series. That was really the bulk of what I was looking for. A number of you put additional information there, which I appreciated. Alright, for the two following scenarios, I want to sketch an ammeter and a voltmeter. How do you measure the current in R1? Alright, you put the ammeter in series. A number of you did this thing where you hooked up a wire here and you put an ammeter here and hooked it up into R1. That is not correct. Alright, you have to put it in series, so you have to actually put it into the wire. I'm not sure exactly what you intended with that, but as it was drawn was not really correct. So I generally took off a point or two for that. For R2, most of you got this. You hook the voltmeter up in parallel, just like that. Following figure shows an ammeter whose full swing current is normally 1 amp. The ammeter is a shunt resistor added to increase its range. The currents are shown in the figure. By what factor has the range of the ammeter been increased? Now, you want to know what is the total current, and the total current coming in here is 10 amps. So now this ammeter, which has a shunt resistor added to it, instead of reading a max of 1 amp, it's reading a max of 10 amps. So it has a 10-fold multiplication. Alright, this figure shows a Wheatstone bridge. Derive the equation for the unknown resistance Rx. Alright, so my main focus on this was that you got the equations right for from Kirchhoff's rules, from the junction rule and the loop rule. So let's do the junction rule first. I'll do the top junction. Incoming current is I is equal to Ix plus Ig. Bottom junction is Ia plus Ig is equal to Ib. Most of you got the junction rules correct. And then I take the left loop. I'm going to start here and go in this direction. I get minus IR minus IGRG plus IARA, and that's equal to 0. That's the loop rule. Some of you got the signs wrong on this, and I took off maybe a point if you got the sign wrong. And then for the right loop, I'll start up here. I'll go in this direction. Minus IXRX plus IBRB plus IGRG, and that's equal to 0. Alright, and then I needed to see that you made this leap that Ig is equal to 0, and then these equations simplify. That is that I equals Ix, because Ig goes away in each of them. Ia equals Ib, and then for the loop rule equations, IARA is equal to IR, IBRB is equal to IXRX. And then since these currents are all equal, if I divide these two equations, the currents cancel, and I solve that for Rx is equal to R times RB over RA, and that's what I was looking for. But the main bulk of the credit came in these equations, and if you got those right, then I generally didn't count off a whole lot for the remaining. Alright, what is the equivalent? It's pretty simple. 1 over 2 plus 1 over 6 plus 1 over 3. That's equal to 1 over, let's see, 3, 6, 4, 6, 6, 6. Of course, equal to 1 ohm. Most people got that.